Hello and greetings, students. Getting ready to start our last subject matter on logic and reasoning. Okay, real quick. There's that big outdoor shopping store that men especially love. Not that I'm trying to be sexist or anything, but what is the name of that? Outdoor, where they sell boats and fishing gear and sporting gear. It's huge.
Isn't it like the Bass one?
Bass Pro Shop, yes, the Bass Pro Shop. I actually have never been in a Bass Pro Shop,
Neither
but
have
they
I.
look amazing.
No, they
Okay, so I need to go down there. I did hear, by the way, the Bass Pro Shop is having a sale on canoes and accessories. Canoes and accessories. I hear it's quite an ordeal.
That one went right over.
Quite an ordeal.
Ordeal. Did you use it? I got you.
Dun dun.
Good job.
Yes, Sophie. All right. So our last learning target, 2.3, postulates and diagrams. Postulates and diagrams. It is a short section. But before we get into it, let me just have a little warm-up exercise. We have this figure here, okay? And if you're watching this on your own, I would maybe take a picture of this figure because I zoomed in on it. That way then you can answer the questions, all right? So this figure they've drawn here, and what they want you to do is look on there and use that diagram to determine which of the following statements you can assume to be true. Which of the following can you assume to be true? So letter A says all the points shown are coplanar. Yes or no, Sophia?
I wasn't paying attention since the beginning.
Okay, all the points. You look at that figure. Can you assume all the points are coplanar?
Yeah, they're all on the same plane, aren't they?
What's that?
They're all on the same plane.
Yeah. Yes, absolutely. They're all in the same plane. They're sitting there on that gray piece of paper looking thing. They are coplanar. Points D, G, and I are collinear. Can we assume that D, oh, I have on white, that's never good. D, G, and I, can we assume they are collinear? I have a yes and I have a no. The answer is no. It looks like, if I erase what I drew there, it looks like I could draw a line that would connect them all. It looks like it, but you cannot assume that's to be the case. The line actually has to be drawn. So do not assume they are coplanar. The next one says points A, C, and H are coplanar. So I have A, I have C, I have H. Can we assume they are coplanar? Yes, they're all on the line that's already drawn right there. So we can assume they are coplanar.
Collinear.
Collinear, thank you. Collinear. Line EG and AH are perpendicular. Line EG and AH. So line EG is here. AH is here. Can we assume they are perpendicular? Why, Latasha?
Because the right angle box.
Because you've got the little right angle red box right down there. So that is the indicator that they are. How about lines? Erase. Oh, it's been annoying. There you go. How about lines A, F, and B, D? Can we assume they are perpendicular? The answer is no, because it does not have the box. Now, you look at it, it looks like it could be perpendicular, but you cannot assume that. We talked about, that's why we're doing this whole logic and reasoning. I'm trying to get you to let go of things to assume and only go with what you can prove to be true. Okay? That is the whole point of this. All right, we have angle BCA and ACD are a linear pair. BCA and ACD. Here's angle BCA and ACD. Are they a linear pair? Do they form a straight line?
Which ones?
This angle and this angle. Those two angles, when added together, make a straight line.
Yeah.
Yeah, they sure do. It's right there, line BD. Okay, that can be assumed. You have a straight line there. If it wasn't a straight line, if it was that subtle, they would indicate to you otherwise. All right. AF and BD, I already did that. EG and BD are parallel. This line and this line, are they parallel? Can we assume they're parallel? The answer is no. There's nothing that tells you that they're parallel. Okay? It has to actually be told. We haven't gotten into the markings for parallel lines yet, but you are not told they are parallel, so do not assume that, even though they, and it says they actually kind of look like they are, but truthfully it almost looks like they're not, if I'm being honest. It looks like heading this direction they're slowly starting to get closer to each other. It may be way, way, way off down on the floor over there before they touch, but it looks like they're slowly getting that way, but we don't know, okay? Do not assume it. All right, that's all I'm gonna work with that figure. There's a couple of things, but I'm not worried about it. Let's actually get into the lesson. So this is lesson 2.3, okay? Again, it's titled Postulates and Diagrams. Here's what you will learn. You will learn to identify postulates using diagrams. Woohoo, there's some complexity, okay? And then sketch and interpret diagrams. So you're going to draw figures, which you've already done. We did that before. And I'm telling you, these next postulates that we are going to look at, you know almost all of them to be true. You just haven't heard them as being called postulates. So that's what I need you to memorize. That's really the only work involved in this, is memorizing these 7 postulates. I'll maybe pause it there for a second. If you want to snap a picture of it, hopefully there's enough on there to snap a picture of it. Do you want to take a picture of it, Sophie, before I move on? Because we're going to go over each one individually. If not, it's in your book. It's loaded up in Canvas. You can access it that way as well, or when we go over it on Monday. So the first postulate, 2.1, is the 2-point postulate. None of these are complex. In fact, these are almost like common sense. So the 2-point postulate states this: through any 2 points, there exists exactly one line. Right? You have 2 points out in space. There's only one line that exists that can connect those 2 points together. It is the 2-point postulate. Okay? These postulates may seem pointless, but they're not. All right. There you go. That's a freebie. All right. 2.2 is the line-point postulate, which is almost kind of the inverse. A line contains at least 2 points. Right? You can't have a line that only contains 1 point, then it's just a point. So a line contains at least 2 points. And between any 2 points, there is a line. So you have the line-point postulate and the 2-point postulate. Okay? This next one, again, you know this already. The line intersection postulate. And again, for some of you are going, what's postulate mean again? I already know that's being thought out there. What's postulate mean again, Sophie?
I forgot.
Exactly. What's postulate mean?
I wasn't listening.
That's just nice. It means rule. Okay? The line intersection postulate. If 2 lines intersect, then their intersection is exactly 1 point. Right? Wherever they cross, it's 1 point where they cross. No big deal. The next one is the 3-point postulate. We've already discussed this at the very beginning back in 1.1. Any 3 points can exist on one plane, right? Through any 3 non-collinear points, there exists exactly 1 plane. So you have the 2-point postulate for lines, where one line connects 2 points. When you have 3 points that are not collinear, remember we talked about that as well, that are not collinear. Think of like a tripod, like what the camera sits on. Those 3 ends of that tripod all form a plane, which is the tabletop it is now sitting on, right? So that's the 3-point postulate. And then the converse to that, much like the line, the converse is the plane point postulate. A plane contains at least 3 non-collinear points. It's kind of the reversal of what we just said. So you've got the 3-point postulate, which is the 3 points exist on one plane, and then the plane point postulate. For any plane, there is at least 3 non-collinear points. 2 more to go. The plane line postulate. If 2 points lie in a plane, then the line containing them is also on the plane. That seems very obvious, right? So you have this. Let me grab a piece of paper. Let me grab a marker. Doing this on the fly. Actually, if I grabbed a marker right behind me, that would have been smarter, but you know it's me, so whatever. All right. So you've got these. I've got this plane. A plane. On this plane, I have 2 points, right, that exist on this plane. Our postulate back here said the 2-point postulate is, what did the 2-point postulate say? Through any 2 points, there exists exactly one line. So I have these 2 points. I connect them with a line. It's not very straight. What this postulate states, the plane line postulate states that if 2 points lie in a plane, then if I connect them with a line, that line also exists on that plane. Really, really obvious. This last one, you guys already know this as well. The plane intersection postulate. Where 2 planes cross, wherever they cross, they form a line. You already know this, right? In this drawing, the line is line L. Okay? The plane intersection postulate. Those are the 7. None of them are groundbreaking. Almost everything, if not all of you already know, or it makes sense. The thing is, you have to memorize them, because on your quiz, I'm not going to give you the names of the postulates. You're going to have to state them. So you do have to memorize. That's the only challenge to this section, is memorization. So, here's some examples. State the postulate illustrated by the diagram. If the 2 lines cross, then the 2 lines cross, and you see the red point they form. Which postulate is that? I believe that is the line, if I remember right, that is the line intersection postulate. It is indeed. Where 2 lines intersect, they form 1 point. That's the line intersection postulate. Letter B, if these 2 planes intersect, then they form what's in red. Sophia, what is that in red?
That's
What do we call that?
the line.
A line. So this is the plane intersection postulate, where 2 planes intersect, they form a line. That's all that's involved in that. All right, now that gets a little bit more complex as we throw a little bit of a more challenging figure at you. Please look at this figure and just get it in your mind what this figure is showing. If you can see it, I don't have 2 pieces of paper ready, but it's as if two planes are coming together, one over the other. Let's do this. Okay. They are intersecting like such.
I think they understand.
I like to be visual. I understand. So sassy. So it happens to get to be a senior, it gets sassy and cynical. All right. Look at that beautiful construction. Wow, I am an artist. Miss Fortune, watch out, I might take her job. All right. Okay, this is what that looks like. 2 planes that intersect. Okay, and clearly they've shaded them differently so you can help visualize that. The darker plane. What is the name of the darker plane, Sophia? Give me the most basic, simple answer.
P. No, P.
P is correct. Plane P. And then the lighter plane is named what, Latasha?
Q.
Q. Very good. Plane P and plane Q, they've crisscrossed. We have 2 lines and a dot, a point drawn on those. Okay? So it says, use the diagram to write examples of the plane point postulate and the plane line postulate. So a reminder, the plane point postulate states that with any plane, it contains at least how many points, Sophia? 3 points is correct. So the only one we can talk about here is plane P, and we see that plane P contains 3 points, A, B, and C. And they are not collinear, so that is okay. 2 of them are on the same line, that's fine. They just can't all be on the same line, right? That is the plane point postulate. And then the plane line postulate just states that where 2 planes cross, they form a line, right? And in this case, that line is called line M. That's all that is. Easy peasy, lemon squeezy.
Justice for Sarah.
I don't care about justice for Sarah right now. All right.
Wait, Sarah the sophomore?
Yes, Sarah Octave, yes. I roasted Sarah at one point for, as I roast everybody, right?
Bad Dr. J.
Bad doctor, bad J. All right. That's why they're petitioning for me to get mental help. But anyway, I roasted her one day, and so then Aliana and Lourdes jumped on that, and then they start hashtag justice
That's such a
for
pretty
Sarah.
name. Lourdes. Continue.
All right, I am continuing. So here is monitoring progress, where you are now supposed to do the work yourself. So if you're watching this, read the instructions and then pause. So it says use the diagram. Oh, I'm sorry. We'll pause now. And we're back. All right. So the first one says use the diagram in example 2. Which postulate allows you to say that the intersection of plane P and the plane Q is a line? Okay. So looking at example 2, plane P and plane Q, what is the postulate that says it is a line? Okay, I don't know, that's almost like a redundant question. That's confusing me. Let me make sure I'm not missing anything because I think we already did that. I believe that is the plane intersection postulate. Oh, maybe it's asking it that way. No, it's not. The plane line postulate, one in the plane. Oh, I said that one backwards. Oh, I see, the plane line postulate. All right, this is going to require me to retract what I said earlier. This one asked for the plane line postulate. I gave you the plane intersection postulate. Went over the example. The plane line postulate here states that if 2 points exist on a plane, then the line that connects those 2 points also exists on that plane. Okay, so in this particular example for the plane line postulate, we have plane P. It has 2 points line on it. What are those 2 points on it that we can connect with a line?
A and B.
A and B, right? Points A and point B exist on that plane, thus the line AB also exists on plane P. That's the plane line postulate. The question you just worked on is the plane intersection postulate states that where those lines intersect, they form line M. Okay, sorry I went that out of order. I don't have time to rewind and edit. Plus I don't know how to edit, so you know, it is what it is. Number 2, use the diagram and example 2 to write example of the postulate. The 2-point postulate. What's the 2-point postulate?
2 points make a line?
Between any 2 points, there exists exactly one line. So where do we see that here?
A and B.
Line AB, right? You have these 2 points, A and B. Between them is exactly one line which is drawn. It's actually line N. Right? You can call line AB, but line N goes through those 2 points, right? The next one says the line point postulate, which is just the converse of the other one. That with any line contains at least 2 points. So the way you would state this for this particular one, you would say, for the line point postulate, line N contains at least 2 points, and line N's 2 points are points A and B. Okay, it's just the reverse of what we did. And then finally, the line intersection postulate. Ladies, what's the line intersection postulate state?
Don't look at me. I passed geometry.
What is the line intersection postulate state? Here are the words in the line intersection.
Line makes a plane.
No, they make a line.
When 2 lines intersect, what do they make?
A plane.
The line intersection postulate, where 2 lines intersect. If 2 lines intersect, then the intersection is exactly 1 point.
Ugh.
So let's go back and see.
No one's gonna remember that.
Okay, where 2 lines intersect, they form exactly 1 point.
Oh, I see.
What is represented in this figure?
Point
with that?
A.
Point A, right? Line M and line N intersect at point A. That is the line intersection postulate. All right, last page of this description. Sketching and interpreting diagrams. So example 3 says, sketch a diagram showing line TV and segment PQ. Please, when you draw these, pay attention. Right, you do a line, I should see the arrows. When you do a segment, it should end at the points. They intersect at point Q so that TW and segment WV, what does that symbol mean again?
Congruent.
Congruent. They're congruent. So as you can see, line TV is here, okay, with the arrows. Segment PQ is here that ends in the 2 points, and then we want to draw the T and the V in such a way, you don't have to, but the closer you can make them look equal, the better. But what's most important is to indicate that what must you include to make sure that everybody knows they're congruent. What do you need?
The tick mark.
The tick marks, right? Those red tick marks are what is required to show that those 2 segments, TW and segment WV, are indeed congruent. All right? Let's see, then this says, a line is a line perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects at that point. Notice, what kind of statement did I just read to you in general terms that you've already learned in a previous unit for this? What kind of statement was that?
All I know is the if, then, whatever.
No, that's not all that you know, Sophia. It had if and only if. What did we call that statement that had that? Biconditional. That was a biconditional statement that I just read, okay? So again though, a line is only perpendicular if the line intersects the plane at a point and is perpendicular to every line in the plane that intersects at that point, okay? So line T is perpendicular to this plane at that point. And any line is also perpendicular to any line that also intersects at that point. So it is perpendicular, line T is perpendicular to line Q, and it is also perpendicular to line AP because they all intersect at the same point. Okay, so look down here, interpreting a diagram. Which of the following statements cannot be assumed from the diagram? Which cannot. Okay, points A, B, and F are collinear. A, B, and F, are they collinear? A, B, and F. Are they do they exist on a line that we can see?
Yeah.
Yeah, they are collinear, so we cannot assume, or we can assume they're collinear, so that is not an answer. Points E, B, and D are collinear. E, B, and D. Can we assume they are collinear? No, we don't see any line connecting them, so we cannot assume that. Line AB is perpendicular to plane S. Okay, line AB is perpendicular to plane S. Can we assume that? Do we see anything that gives us an indication that we formed a perpendicular line?
Yeah.
Yeah, see the little red box right there, right? It's telling us it is perpendicular, so yes, we can assume that. Now comes the trick. Can we assume that AF, why do they have to use AF? All right, line AB. I'm going to use line AB. I want to be appropriate. Line AB
You literally could have said FA.
intersects, it's true, BC, oh no, I'm jumping ahead, sorry. Line CD is perpendicular to plane T. Can I assume that?
That is perpendicular?
Yes.
There's no mark though.
Can we erase that one?
Oops. What the? There we go. We're talking about line CD. Can I assume it is perpendicular to this?
I'm tripping out.
The short answer is no, you cannot, because there's no right angle indicator given to you there, okay? Then finally, AF intersects BC at point B. Clearly that does happen. Line FA, as I'll say, does intersect line BC. Oh wait, at point B? Yeah, right there. I've marked it all up, but yes, we can assume that. All right, the last thing, this is it, is the monitoring progress. Okay, referring back to example 3. So again, I'm running out of time because it's 12:09, about to hear the bell. Take a picture of this, then go back and work on it, and we'll discuss it together in class, okay? Looking for 3, 4, 5, and 6, and that literally is the end of the chapter. Okay, pretty simple. So again, recapping this, your biggest thing you need to do is memorize those 7 postulates. None of that information is new, you already know it, you just need to memorize it, okay? See you on Monday.